Today we will see the heating surfaces, the manufacturing of heating surfaces are the coils or coil bundles. The raw materials you can see here, this is a stainless steel tubes, and you can see the size given here, and this is a Tubacex is the manufacturer, 54 dia OD and 5.6 millimeter, and this EN specification to which it confirms the manufacturing 10216, and material specification and other things are printed. What is the kind of surface finish and the treatment conditions to which it is supplied. So we get the raw material as long tubes, 11, 12 meter, 13 meter, 40 meters, standard length up to 12 meter. Any extra lengths required will be according to the requirement of the customer, and agreement will be made accordingly. So any short length also is possible if you need only 10 meters all, because of this saving of the material. If the design calls for 10 meters, and if it is 11 meters, if 1 meter is going to waste or it has to be joined to make it, then to avoid that, the specific length of the tubes you can order. This is a typical small tube bending machine. Coils or heating surfaces, the majority of the operation is, one is to make up the length is a welding, tube to tube welding. That is a special process again. Machine welding is adopted here because of large quantity of butt joints to be welded. To make one coil, we need to weld many tubes, and so the butt joint welding is done by TIG welding mostly, because it is highly efficient and also faster, and without any cleaning in between. If we make SMAW, for example, the arc welding or stick electrode welding, each pass we have to clean, and the process is manual and it is very slow. And in between, there are chances of getting a lot of defects, slag inclusion or no fusion or excess penetration like this. So the tube butt joint welding is mechanized. Here you can see a tube bending machine. You can see here a small tube. This is for trial testing. The tube is held in the die. You can see the die here, and the machine is operated by electric, and also there are hydraulic controls. So the die here, the round one will rotate, and the second side one, it moves along. So there are different kind of machines, modern machines. They are called booster machines. Without booster, it only rotates and it pulls. With booster, this also moves along, and tube bending takes place because one side it is held firmly, and it rotates. So tube bending machine. So you can see here tube bent here, 180-degree bend. So the tube bending calls for the radius. The radius normally is the minimum radius that can be bent is normally without any special requirements, is 2 times the diameter of the tube OD. And then any bigger radius is not an issue, because smaller radius than the tube diameter itself will have to be less than 1 is not possible. Radius less than 1 times diameter is not normally allowed, because not possible to bend without having wrinkles or tube itself bulging or damaging. So normally 2 times the diameter radius is normally done. So after bending here, you can see is put on the layout. Layout is nothing but the sketch according to the drawing. What is given in the drawing, the same thing is drawn here on a base plate. Is a plate, and then is the marking is done like 0, 30, 45, 60, 90 degree. This is the marking division, and this is the center line is there, from where we can measure. The layout itself has to be qualified first, whether that is drawn according to the drawing, and then once the layout is qualified or inspected, then we put this bent tube on the layout and check whether the bent tube is properly according to the drawing, because this is a first piece, sample piece for getting the required dimensions. And also the bending, you can see the outside, even after stretching, the tube should not have any defects, no crack, no breakage, or should not be having a waviness or wrinkles. All these parameters has to be checked. So for this reason, the machine is adjusted. The die punch, the clamping, and the speed, movement, all these things matters. So once we start, before starting, this test has to happen to qualify the first piece. So normally this is called as a test piece. So this after bending, we also make a sections. That is the reason we put here 0, 30, 45, 60. This is a code requirement. So in this areas, we have to cut the tube and check the ovality. So when we make the tube bending, the tube diameter cross section will not be same all around. So because we are stretching, the uniformity, it cannot be exactly as a raw material tube before bending. So we will check how much there is a ovality. Ovality is nothing but deviation from the concentricity. So that means when we check the tube as received from the manufacturer, diameter is all over will be almost same, maybe very little deviation. But when we make the bending, the deviation is higher because of deformation. So but there is a allowance. We cannot make 0, 0. So this operations calls for stretching, and inside is compressed, outside is elongated. So in the middle neutral axis, there may be again no cross-sectional deviation, no stresses, but we make the sections and measure the ovality. So there will be 2 diameters. One is minimum diameter, another is maximum diameter. From this minimum and maximum diameter, we calculate the deviation. So that is given for which diameter of the tube, and what thickness and what radius of bending, how much is allowed. So there is a formula. So accordingly, the ovality is measured, and whether is acceptable or not acceptable, that is decided. Is a bend here. You can see the 90-degree bend here. Another tube require 90-degree bend. The sample after bending will undergo NDT test. NDT test. This test is a particular test is called PT test. Yesterday I have shown you PT test with red, and here after red is applied first, liquid penetrant. So around 10 minutes is allowed to make it penetrate into defects, if any, and then it is cleaned. The surface was cleaned with the cloth on the surface. Whatever is there remaining on the surface, excess without penetrating, so that only is removed, and then after cleaning, this developer is applied. So once the developer is applied, so if there are any cracks or any holes or defects, the penetrant has gone inside and stay there. When you put the developer, the developer absorb or pull out the red color penetrant. So on the background of white, we can see red color dots if there are any defects. So this test is done to qualify that there is no defects. And the visual test is normally we can see the wrinkles and any bulging, so dent marks of the die, if die is not properly ground. So all that is done. You can see the tubes, many tubes bundled here. So each tube is bent according to the required the layout. So each tube is not same here, you can see. So because this has to be made as a bundle, so each the innermost tube has a small single bend, and whereas the second tube from inside, you can see there is a one bend, and then there is a straight portion, and then again bending, so that its location is fixed properly. Accordingly, you can see all the other tubes bent and put into one bundle. Here you can see the welding of the tubes. This is a machine, TIG welding automatic machine, semi-automatic machine, whereas semi-automatic means the tubes, of course, is drawn. There is a conveyor, and that is motorized, and it can move. And when it comes here, the operator makes the adjustment of the two tubes for proper alignment, so that both tubes are aligned without offset, and he will check also the preheating has to be required. Also preheating is done here. So sometimes preheating done by external gas, sometimes the arc itself make one rotation or one round of uh, movement, so that the arc will make the heating of the joint, but without welding. So no fusion, but only the arc makes and tube rotates. So the preheating happens. Here the tube rotates, and the head, which is holding the tungsten electrode, is stationary. So as the tube rotate, the welding happens. The first root pass will be normally without filler wire, and then subsequently filler wire is added and welding happens. This is a very quick, fast process, machine welding. You can see another view here. This welding is not completed. It is in between. So there are 2 or 3 layers welding is done, and you can see the tungsten rod here and the ceramic nozzle or cup, which is protecting the the electrode. Otherwise, surrounding will be very hot. and it does not melt. So the tungsten electrode passes through these, and there is a arrangement for wire spool, and wire spool rotates when the machine is powered on, and then filler wire is made to come near the joint where the arc takes place, and the machine rotation of the tube automatically takes place. All are synchronized so that welding takes place once the one single button is operated. So like this, there are large number of tubes got welded to the required length, and tube bending. Here is another big machine for tube bending. You can see here tube coming from one end from conveyor. There is a lot of tubes required here, stacked on a stacked in a racks, and then there are motors and conveyors and rollers. They operated by electric motor, so we can pull the tube until this machine. So this machine is a very large machine, and here you can see the die and punch under this table. This is at an elevated height from the ground, and from the bottom the die and punch can come up with the hydraulic operations. So die and punch, they are all activated to hydraulic operations, and the control is done by operator sitting in a small cabin, which is not in this picture. And you can see people. This is for testing purpose. Once the test happens, you can see here the radius bent, and once the radius is bent, again the first piece is will undergo the testing for all the required tests, checking, and then they will continue the listening. You can see a small cabin here where the operator sits and operate with the control panel. So this is during, we cannot go near this machine when the tube bending is happening actually, but only this is the stage where we have only single tube bending for testing. So otherwise the tube will be rotating all around this table. So it is dangerous to go near this. You can see here a small white shape with different angle, two pieces joined. So this base plate is a carbon steel plate platform, and whereas this is a material which is not a metal, is some fiber material or a plastic material. It is a or a Teflon material. Is a white color. You can see this is to see that the stainless steel tubes which we are using for bending the raw material under this consideration should not get in contact with the carbon steel. Stainless steel is a special material, should not get come into contact with the carbon steel, because when it is bending, the whole tube rotates, and the full length of this will come in contact with the table, which is carbon steel or black material, and get rubbed together and make not only damaging, also make the contamination. The surface of the stainless steel tube is treated with acid wash, and the surface is meant for preventing the rust and corrosion, so that the scaling is formed during that treatment. So if we remove that small, it is in microns, small surface thickness, which is protecting the rust, and then it will get corrosion, then it will get corroded. So the very purpose of using the stainless steel for primarily is, it is not a corrosive, and it is not a and it is also withstand very high temperature and pressures. So corrosion is very important here. So because it operates at a very high temperatures in the boiler, so it has to withstand and come for a serve for a longer period of let us say 15 years, 20 years, or 30 years. There are boilers even in our Raichur thermal power plant which are operating even after 25 or 30 years. BHL has built these plants, and but it was like a 220 megawatt boilers, and it was a two pass boiler. It's not a tower boiler. Now in Raichur, nearby Raichur, Yarmaras, called the name is called Yarmaras, around 20 30 kilometers from Raichur. There is another plant come up which is 800 megawatt, 2 units. That is a supercritical boiler. And this is a tube bending machine. Okay, another photo. You can see the tube identification, as I told you repeatedly earlier also. So this each tube has to be identified for its project, its specification. There can be a unique number. Only by knowing this unique number, for example, here they write G153-01 -10-4 and -1. So if you only get this number, the record will tell you what is the meaning of this 135-01, which to which drawing it confirms, or which part it confirms. And then from there we can get the link for other details of like what is the heat number, what is the batch number, who is the supplier, all these things. Every time, every part of the material has to be traced back to the supplier and its material certificate. You can see here there are tubes bent and kept on the machine. This is a carbon steel material or black material. This we have seen earlier. So like this, the whole bundles are made and bent according to each drawing, and then they are put together and becomes a complete coil bundle. So you can see here the assembled one. There are not so many attachments in the coils or these heating surfaces, but there are. You can see here, for example, these tubes where we see here closely are the tubes which carry the whole coils. They need to be supported, right? So this there are two tubes, and here there is a plate, small plate welded between these two tubes, and there is a hole in that, and the coils are passing through this. When we are assembling this coil, we will insert this and then get assembled. So here you can see there are small plates, supports which have holes. These are for arresting to the steel structure. So here you can see this tube end prepared, and this gets welded to the next level pipe or tube. This is. So you can see in the rear side there are a lot of assemblies done and stacked. Here you can see one thing in the coil. When we have the in the furnace burners from all four corners, there are coils which are very close to the burners. So when the burner is directly hitting the flame, there will be some gap, but but even then, those coils which are nearest to the burners get the pinch of the burner and also the tube will get the heat, and because of this, the tube which is closest to the burner will get damaged, which gets eroded because of continuous hot flame. So it gets slowly gets melted, and sometimes it will also get melted when the thickness becomes less. From the beginning, small particles coming out and thickness gradually reduces, and then once it may break or may become whole or puncture or melted also. So that is the reason here there is a shield provided in order to protect the tube from the flame, which is continuously uh, burning. And these tubes, the plates which are covering are called shields or covers, which are of different material than the tube, for the reason that this has to be more wear resistant and also withstand higher temperatures. And this is welded around the tube. You can see the other side, and there will be a small area where they get locked, so they should not move or they should not rotate. Here you can see the inspector doing the inspection of the raw material. Before taking into the assembly or any preparation, the raw materials will always undergo inspection at different stages. The first stage is the inspection of raw material, the batch number, heat number, the lot number, and the size and the thicknesses are all checked. You can see here, these tubes are just bent and not assembled yet. So once they start bending, one size of the tube they will take first, because each bundle have different coils, and each coil is different. Its layout is different. So each kind of a tube is started bending, and then they will finish. For example, if they need say 100 pieces of the same for different bundles, the same tube they will start bending, and then they will put it together. So like this, and then the identification will be there as which is the coil number and which is the tube number. So accordingly, assembly people will take each one of them, and for one bundle they need coil 1, coil 2, coil 3, coil 4 or 6, and like this they will insert one into the other according to the layout, and they will start assembling. And on the layout, they make also attachments as the protective shield, and along with the supports. There is one. Yeah, you can see here the assembly area where they are making assembly. You can see here the supports which are fixed. It is kept on a base plate at a little higher place, on a support or on a platform. This is the channel or steel structure. On that, these coils are supported, because we have to work, we have to move the tubes in order to make machining. Here you can see the tube ends are machined. The tube lengths kept during the bending somewhat extra, longer, say around 25 or 30 millimeter extra sometimes, sometimes exactly only 10 millimeter extra. depending on the accuracy they can bend. And finally, before sending to the assembly, to the dispatch, we have to prepare these ends. The edge preparation is done here by a small portable machine. So when we have tubes, pipes like header pipes we have seen earlier, we cannot machine it, the big size ones, by a small portable handheld machine. So that has to go to the bigger machine for turning. But whereas here the tubes are very small, and there are machines which can machine in the same location, small portable machine like we have seen small drilling machines, electrically operated machines, and there will be also pneumatically operated machines which can take higher loads because of its sturdiness and heavy structure. You can see here, this is the support, are also called as hanger tubes. The hanger tube is inserted between two layers. You can see we call this as a bundle also. The reason is there are two layers of the coils, one at the top and other at the bottom. So these two layers having one support in the middle. This is also nothing but a tube. This tube also act as a heating surface, and here in this case superheater 2, which is near the furnace transition area, starting from there it passes through right up to the top of the boiler, and this tube also carry the steam. So this tube, since it also hold all the coils in the boiler from this transition area up to the economizer area, so this has to be very strong. For that reason, this is a material is carbon steel normally, and this is P91 or P92, and also it is of heavier thickness because of load carrying requirement. So you can see here there is 1, 2, 3, 4, 5, and 6, around 6 supporting tubes are there, and I will show you one small separate supporting tube picture. So here you can see it is only put on the left. This is a this coil is a superheater 2, which is starting from the uh, transition area. This is the bottommost coil in the whole boiler, and this coil itself turning into a supporting tube here. So this tube, from these two tubes coming here and making one by a forged piece. This forged piece having two V-shape openings, and then the tubes get welded here, and it is converted into one diameter. And this side, the supporting tube which we have seen just previously, get welded. So this will continue as two tubes. I want to show you the single supporting piece which is under welding. I think not here. Okay, try to catch it from. Somewhere I think. Yeah. Where is that? Yeah, here. Yeah, you can see here the individual small hanger tubes are welded here, and these tubes are, as I told you, little heavier, minimum 8 millimeter thickness, up to 10 or 12 millimeter thickness in some areas. And you can see these plates are profile plates which are holding the tubes, as we have seen earlier. So this welding is, you can see, plate to the tube welding, very smooth. This is a robotic machine has welded, and not always a robotic welding machine. So also possible that we make this welding by arc welding or by MIG welding. You can see here the robo making welding here, the tubes and fin. You can see the shape of the plate here. This is exactly made to suit the diameter. In different areas, the tube diameters are different. Accordingly, the profile is made, and they are holding this profile area is holding the tube, and this is the robo for welding. So this is about the heating surfaces, and you can see here the one which is manually welded. This is a little different kind of a plate. There earlier we have seen a plate which is continuous, that was designed for allowing for continuous welding. When there is a continuous plate, the robo can weld continuously. If there is a plate like this, which is small individual plates, but not continuously welded to the tube. So for that reason, this is welded manually. Yeah. So now it is 9:26. I think you have to get ready for the next class. So I will stop here. And if you have any questions, you can ask me.
So, students, do you have any questions?
In this picture, as I was telling, I wanted to show you one example where there is a defect, how it looks. If we make a penetrant, dye-penetrant testing or PT test, normally called as, after applying the developer, the white color developer, in the background you can see the red color. That red color, after in the joint area it is cleaned. In the other area in the tube it is not perfectly cleaned, but never matter. So you can see a small V shape shown here to identify the small dot which is in red color. If there is any small defect, small pinhole by eye, by naked eye, we cannot see this. But when we apply the penetrant and wait for 10 minutes, the penetrant will go into any defect and then stay there. And only we remove the excess penetrant at the top or surface, and then we apply the developer. And then after applying developer, slowly whatever that has gone inside, if there is a defect, that comes out. And that on the background of this white color, the patch is seen. This is a small defect, very, very small defect. We can see even much bigger defects, but in this welding is not many. So, yes.
Okay, sir, students, I think students, they don't have any questions to ask.
Okay.
Time running out. So tomorrow also same 8:30 to 9:30 will be there. Tomorrow some half an hour description about the different.
If you all join at 8:30, it is better because we are losing 15 minutes in the beginning itself.
Yeah.
So, yes.
8:30 to 9:30.
Okay.
And so different parts of the boiler, and where it is situated inside the boiler, how it is fabricated, such information will be given, and there will be interaction with among everybody, and tomorrow will be the end of this industry person talk. And
Tomorrow I will show you one video of boiler inside the burning. I have one video that I will show you tomorrow.
yeah, so
Just one second, I wanted to share here a panel with the holes. I have told you the heating surfaces coils which are inside the furnace has to pass through these holes through the panel or water valves, and they are connected through connecting tubes to the headers. So here are the place where the heating coils penetrate, and for that reason these holes are made in the panel, and these tubes are there. In between tubes there are plate or fin material. So on this fin material the holes are made, a series of holes, so many holes as many as tubes.
no.
Okay.
Okay. So next tomorrow will be it will be continued tomorrow.
Okay.
Thank you, sir Ramesh.
Thank you. Thank you all.
All the students can leave and join for the next class. So hope you have put your USA number in the chat box.
Okay.
Okay, sir. Thank you.
Thank you.